Welcome to the AI Research Roundup. I'm Alex. Today, we are looking at a paper from the Hugging Face trending list, published on December 11th, 2025, about 2 days ago. It introduces InternGeometry, a large language model agent that solves 44 of 50 International Mathematical Olympiad geometry problems, while using only 13,000 training examples, just 0.004% of the data used by Alpha Geometry 2. The paper is titled, Achieving Olympia-Level Geometry Large Language Model Agent via Complexity-Boosting Reinforcement Learning. And as we will see later, the results are really impressive for both data efficiency and expert-level reasoning. Figure 1 shows why International Mathematical Olympiad geometry is so challenging and why smart constructions matter. The left panel presents the original statement of problem 6 from 2018, which looks like a simple quadrilateral with one interior point and a few angle conditions. The right panel then adds many dashed circles, lines, and extra points, which are auxiliary constructions that reveal hidden relationships. These extra objects do not change the original problem, but they create new equalities and symmetries that make a rigorous proof possible. Figure 2 explains how InternGeometry actually works, showing both its reasoning loop and how it learns from harder and harder problems. The top block depicts the agent cycling through think, action, and feedback steps, which use a domain-specific language, meaning a small custom code for geometric constructions. A dynamic memory module compresses the long histories so the agent keeps only key moves and results. The bottom block illustrates complexity-boosting reinforcement learning, where synthesized training problems gradually increase in difficulty and yield binary rewards that update the agent policy. Table 1 makes the headline result concrete, showing that InternGeometry matches or beats specialized geometry solvers while training on far less data. The table compares 3 systems by model type, training set size, sampling strategy, and how many of 50 Olympiad problems each one solves. Pass at 256 means the run counts as successful if any of 256 sampled reasoning attempts finds a valid proof. InternGeometry appears as the only large language model agent in the list, yet it reaches the best score with orders of magnitude less supervision. Figure 3 shows that letting the agent think for longer dramatically boosts its chance of finishing a correct proof. The left panel plots pass at k, meaning the probability that at least one of k attempts succeeds, against the maximum number of interaction steps, and success climbs steadily as the step cap grows. The right panel holds total compute roughly fixed and compares adding more samples versus lengthening each trajectory, revealing that longer trajectories give much better gains per unit budget. Together, these curves argue that deep, long-horizon exploration matters more than just trying many short runs. Figure 4 shows that the training curriculum steadily increases problem difficulty, and the agent keeps getting better as a result. The left plot tracks proof length, which is a proxy for task complexity, and it rises almost linearly across schedule update rounds. The right plot tracks pass at 256 on the International Mathematical Olympiad 50 test set, which climbs in tandem with a sharp jump around round 6. This pattern suggests that complexity-boosting reinforcement learning creates progressively harder data that directly drives large performance gains. Figure 4 already suggested that the curriculum matters, and Table 4 now quantifies how big that effect is. Complexity-boosting reinforcement learning, which steadily raises problem difficulty as the agent improves, lifts performance from about half the problems solved to nearly all of them. Training on easy synthetic problems only or hard ones only performs much worse. Even using the same mixed data without the difficulty schedule trails the full method by a noticeable margin. Alright, to wrap up, InternGeometry shows that a single large language model agent, tightly coupled with a symbolic prover and a difficulty-aware curriculum, can reach and even surpass International Mathematical Olympiad gold medalist level in geometry with tiny data. That hints at similar agentic setups transforming other structured reasoning domains. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.